Plus it's leafing out there, I imagine, right? So there's a lot of transpiration.
Look at that.
Okay, we are ready to go.
Okay, welcome to our discussion for this Friday. This is a wild Friday. April 14th, 1935, it was the biggest dust storm of the whole Dust Bowl era that occurred. I don't know if it was a Friday, but Friday the 14th of April was the day Lincoln went to the play and didn't come home. So a lot of stuff on the 14th of April. We have had quite a week here though, really, and well forecasted in a couple of places. Now, number one, everyone knew there was going to be this beautiful gradual spring to almost summer warm-up that we experienced with an 82 for our daily record on the 13th yesterday. I think their previous high was 78, so it was kind of a bald spot in the as the records go. They've all been mid to high 80s around this middle part of April, but not yesterday's date, the 13th. So we set a new record with 82 on the 13th, and we'll probably be around 80 or maybe even a little higher today. But I think the record is something in the mid to high 80s, 87 or something like that. So we don't have a chance for the record today. We came close on Wednesday, but missed by 2 or 3 or 4 degrees. But a pretty nice week in terms of the warm-up. But to my feel, I guess, not too hot, too fast. So it took all week to get to 82, which is really nice. Highest dew point of the week was maybe 56 or 7 on Wednesday morning. It was pretty muggy. So it was even not that bad in terms of dew points much of the week. But a lot of things happened across the country this week, not the least of which was 25.6 inches of rain at Fort Lauderdale in one day. And it's one little spot, thanks Pete, one little spot right along the coast that got 25.6. Now I'm fairly certain that this will be under investigation. It'll probably be sanctioned by the governor actually to investigate this, because he doesn't want to have to try and explain what's going on here. But it's not the only place that had wild precipitation and somewhat out of context with other adjacent observations. 8.87 at North Lauderdale. That was a spot where it looked a little bit wetter than some others, but broadly speaking, as many as 6 along the coast and 9. But it's not, dozens of observations over 10 inches of rain. And so that's going to require an investigation of that particular report. If it stands, it breaks the daily record there by 10 or more inches in one day.
I thought I read that it broke a 1, a 2, or a 3-day accumulation record. All 3.
I hadn't heard that, so that could well be true. I thought what I read was that the prior one-day record was 14 and a fraction. So this is way over that, and that might not even be right. That might be a multi-day amount. So something has to give on this. We're either going to find that it actually is true, and it looks like it because of the flooding that you might have seen around Fort Lauderdale on the news. I mean, the water just had no place to go. The highest elevation in Florida is 13 feet above sea level, and then you have sea level. So there's no place for this water to go, except some of it runs off. But the flooding was disastrous in this part of the city. So really, really bad. And of course, we're trying our hardest here. This is on the 12th. We're trying our hardest to find what synoptic feature may have been responsible for it. Can we take this down, Pete, and we'll look at the movie that you've got for us? And we don't have a close-up of just Florida, but I'll tell you when we get to the 12th. We're on the 14th now, so we're going to go back.
I could just as I can get there.
And let's just stop it around the 12th. So it's got to be right about there. Go a little further here. Yeah, right about here. So it's got to be the progression and development of this very interesting disturbance in the eastern Gulf of Mexico. Fort Lauderdale's right about there. And is that right?
I was thinking these were 10-minute images, but they're actually half an hour. That might make more sense.
Okay.
Because it was several images where there was something going on.
So
that's like,
none of them have exceptionally cold cloud tops over the region. I think I'm in the right spot too. It's right here, right, Fort Lauderdale?
So it's just north of Miami, right?
Yeah, I think it's got to be further south. So maybe right there. That's on the 12th at about 6 p.m. GMT time, so for them about noon time. So that's the coldest cloud top that you see, and then by then there's nothing going on after that. So when we're still just barely into the early hours GMT time of the 13th. So it's this southern piece right there. Go back a couple times, Pete, right there. So that must be the feature. Now we'll try and put this in the context. 18Z on the 12th. There is this really interesting cyclone developing down here south of Louisiana that has a short lifetime and it moves inland and it kind of decays a little bit. We'll talk a little bit more about that as its own feature. But this is what we'll try to do is interrogate some of the synoptic maps on and around the 12th of April and just see, is there anything, first on the very large scale, that explains this cloud shield and any development that might be going on, although I think the development's farther to the west, and try and piece something together about that. Now, don't animate it yet. While we're going, there's this big cyclone south of Greenland that has a beautiful cloud situation associated with it, street associated with it. Kind of breaks up a little bit, no high clouds here, but this looks like a continuous part of that whole swath. And I think when we look at the water vapor, you'll see this dry slot. It's right back there across the whole thing. So this portion of the development on the western end of this broad cloud feature associated with the cyclone south of Greenland is probably the culprit for the Fort Lauderdale flood. And how exactly is something we won't determine today, but we can talk about some of the characteristics of the environment. And then this is the first of two cyclones that are making their way off the northeast part of North American continent. And you can see, here's the second one, smaller scale, in the wake of the first. And one other thing that's neat about this movie, we'll animate it again in a minute, but this is, mid-afternoon for us, or early afternoon for us, and you can see how warm the entire continent is, and especially in comparison to the lakes, where their color in the infrared doesn't change at all as you watch the animation in just a second. But the contrast between the land and the lake gets huge very fast when the sun's out and it's mid-April, as it just about is now. So maybe we'll animate this, Pete. And so look at how the lake color doesn't change, but it's about the same as the overnight temperature, and then boom, it just explodes. So let's watch the development that goes on in the Gulf of Mexico. Here we are on the 10th, almost the 10th. Okay.
There's a little wave coming off of Texas that.
Yeah, and here's the beginning of the development. You can see the swirl there south of New Orleans. And that's, well, we're at the end of the day on the 13th or 12th now. And there's a pretty decent cyclone, goes up inland and kind of loses a little bit of its coherence. But it's not ill-defined even this morning. So, and it looks tropical, really does look like a little tropical system. I don't know that it is, but it sure has some of the telltale satellite signatures of it. So that's an interesting feature, and there's tremendous shear going on here in the vertical. As a flow from the southwest at high elevation and from the northeast at low elevation. So the strong baroclinicity off the coast of North America that you can see in the satellite picture. So let's take a look, Pete, at the infrared, the water vapor, because I saw you showing that, and that was really interesting. So just right here is a perfect time. This is 12Z-ish, 13Z on the 12th of April. So here's what I mean about the coherence between this structure at the southern end of the Labrador Sea, and look at this dry slot that connects back into this, the dry southwestern part of what's developing south of New Orleans. So that seems to me to be a fairly coherent structure. I wonder what it looks like in upper level vorticity or some other things, because often the water vapor image where it's bone dry like this in the middle latitudes is a signature of pretty high vorticity and in a strip. I don't know if that carries on all the way across Texas. I wouldn't be surprised at all if that's what it looks like here and you got a jet stream right about there, fairly low latitude for early April, if that's true. But look at the cyclone that off the coast of Newfoundland. A couple of swirls, concentric around it, pretty intense disturbance. And then this is the second swath of clouds, and we'll notice a couple of little swirlies that get developed on the shear line from Nova Scotia all the way back to about Sable Island. So can we animate this one, Pete, starting at the beginning? And so we're starting on last Friday, which is the 7th, so it's a few days before we start to see anything related to those structures to which I drew your attention just a minute ago. So here we are at the midday on the 10th. Looks like there is something kind of heading southward out of the Central Plains. There's our big storm off the East Coast. There's the dry strip. Here's the cyclone. Really nice presentation in the water vapor image over Alabama, Mississippi. And then it kind of spins away into sort of non-entity sort of status. And when we get back to the 12th, one last time, we'll just take a look at what we see from the water vapor perspective over Fort Lauderdale. So this is the end of the day on the 10th. Now we're into the 11th. Here comes the end of the day on the 11th. We'll just keep on going. So there's some impressive looking cloud development that characterizes this. We were up 18Z, I think, we were looking at. This feature right there, that's probably it. That was responsible for the short-lived but fairly heavy precipitation. And it's just one of several convective elements, presuming they're convective, that blew up in the downstream of this interesting little wave that appears to be connected to this intense cyclone at the south of the Labrador Sea. So if you took this map and you said, what season or what time of year is it? It'd be really hard to imagine it's December or January. It'd be hard to imagine it's October because you wouldn't have this, and you wouldn't have the empty tropics. Maybe it'd be a good question, and maybe you might be able to just say it's somewhere in the spring. I don't know exactly where, but somewhere in the spring. It might be characteristic of the spring. I don't know. Okay, so thanks for that survey, Pete.
Yep.
Let's take a look at some upper level charts. Wait a minute, first let's look at the current satellite in the visible over the continental U.S. So here's the pseudo color image, or whatever they call it, but it's good, I like to look at it. Here's our cyclone now south of Greenland. Look at this cloud feature, it's all the way down here. I'm not sure that that isn't part of the cold front structure of this disturbance. And so that connects back in a similar way to what we saw just 2 days ago into some convective elements from North Carolina down to the Bahamas. And that, on 2 days ago, was right here in the eastern part of the Gulf of Mexico and flooding Fort Lauderdale. And here's the circulation associated with, I don't know what this thing is, but looked tropical in some other presentations. It looks like a dying tropical cyclone now inland in some ways. And that's over northern Alabama. So that's interesting. We'll take a look at the radar depiction of that in just a minute. Nice clear skies over much of the Central Plains. We'll see temperatures in a minute. They're already really warm. And then here comes some clouds associated with a kind of meridionally oriented developing cyclone that's not quite very strong all the way from northern Minnesota down to about the panhandle of Texas. We'll see that in just a minute. You can see the cumulus clouds sprouting over the Yucatan Peninsula as the sun comes up. Look at that, widespread. And then they start to aggregate, and they get a little bit of space between them because they get bigger in some locations, and they get squashed by the subsidence on the periphery. It's too bad we couldn't get a close-up of that. That'd be really nice to see. But you can see the same thing on the Florida Peninsula. As soon as the sun comes up, boom, they explode, and they don't develop over Okeechobee or any of the other big lakes, of course. Really nice. And the whole southeast is characterized by that today. So it's one of those days where you look at the sky and it's just nothing but mottled cumulus clouds with a low LCL, low cloud height, and a lot of space between them as the day wears on because some of them grow tall. Okay, let's take a look now at some upper level charts. Oh, West Coast image, sorry, I keep forgetting my morning here.
Wait, that's a weak one. I don't want that.
Yeah, you don't want that. So we have two disturbances of some interest. One of them is in the Gulf of Alaska to the east of what used to be called the Queen Charlotte Islands. There's now a native word for it, I forget what it is. It's a better sound, as they all are, like Denali is better than McKinley. And then here's the cyclone well to the west of Hawaii and in the extratropics, but about the date line. It's not very intense, about 1,004, but its structure is pretty nice and illustrative of a decent cyclone in the Pacific. Broadly speaking, though, the Pacific looks kind of boring in this sector. There's a splotchy part of the ITCZ and then a huge gap, like a first grader's teeth, right here over about 70 degrees of longitude. And before you see kind of a weak pickup of ITCZ convection there, I wonder, you know, how the sporadic nature of it influences momentum transport and all that. It's a really interesting question. The synoptic influence of that corrugation of the ITCZ is something that I've gotten more and more interested in on the side. I can't really spend any time thinking about it, except when I talk with Angel about it, which is fun. Okay, so that's interesting, but not of particular importance for us. So let's take a look at some upper level charts, Pete. Try and make some sense. And yeah, we'll use the super Pete. And we better do the move. Let's do the current time first. That's a good idea. So this is 12Z on Friday, the 14th of April. There's our 500 millibar minimum geopotential right over northern Alabama and northeastern Mississippi. And when we go back, we're going to look at movies. I think it's going to be useful to see how did this whole thing develop. As it ends up in a fairly interesting configuration, a fairly deep upper level low for early April, and then look at this ridge kind of completely tilting back to the west. It's almost zonally oriented ridge axis. And that's just a complete reconfiguration of the flow over probably a period of days that's done that. And so we have strong cyclonic curvature and then strong anticyclonic curvature in the ascent maximas over Kentucky and Tennessee, and I think that's where we saw much of what remains of the circulation of that storm. And then a fairly modest trough across the Intermountain West, a more substantial one off the coast, which I think is in association with the cyclone that we saw right here off the Queen Charlotte Islands. And we don't have sufficient regional coverage to see that feature west of the dateline. But it probably has a similar structure, though since that cyclone's only 1,004, I think, millibars minimum, this one's in the 990s, maybe it's not got quite as much cold air, and it's in a lower latitude as well. It's at the latitude of about the Bight of California. And so it's probably not got minus 30 air at upper levels, which means that it doesn't have quite the same temperature advection structure, and therefore probably not as much QG forcing for ascent. So it's a little bit weaker, more weakly forced storm. So what I'd like to do is take a look at the evolution of this level over a period of days, maybe starting on the 11th. I know the movie will go longer than that, but we don't have to see the first few days. And we were talking last weekend, this is good, right there, it's great. We were talking, I think, last week that there was a couple of cold air disturbances over the Bering Sea in northwest Russia, and this might have been one of those that made its way across the little bit of a ridge that was near the dateline. Minus 38 analyzed right off the Queen Charlotte Islands. The minus 35s have the day in terms of real observation, so that's a really cold upper level air mass for early April. And there's a strong baroclinic zone, and look, that's minus 20 and this is minus 35. So you've got, 15 degrees of temperature contrast at 500 millibars on a portion of the western edge of this upper trough. Strong northerly flow. There's warm advection by the geostrophic flow here, and so ascent is likely to be going on right around in that location by that forcing. Maybe it's counteracted a little bit by being upstream of the curvature maximum. But I suspect, I don't know though, I suspect that something out of this complex is what slides its way down across Texas. Let's see if that's right, because we already have a local vorticity maximum over Louisiana by 12Z on the 11th of April. There's something already there. Man, interesting. Can we go back a couple times, Pete? I just got to see where that comes from. Okay, maybe it's this little trough, because there's nothing down there here on 12Z on the 9th. So one more click forward. That's 0Z. So I don't know what to think yet. I know it's not obvious. Little cold pocket here with a geopotential height minimum and some cyclonic curvature. That could be something of interest. That's on 12Z Monday. And then one doesn't really find it easy to trace that feature. One more time gets us to 12Z Tuesday, where we were. A local cold spot, maybe about minus 20, and cyclonic circulation. Weak though it is, these are all 5-knot winds. Okay, let's see what happens at the next time. And that continues to slide southeastward, but not develop very much. The winds are still weak, and we're a little bit warmer, minus 19, but that's okay. We moved further south, so it stayed cold. This is minus 20 now at Baton Rouge, so that's a real ob. So this is colder and colder air. The air is ascending. That's got to be what's going on. There's our upper trough off Washington, and it has nothing to do with this feature. And there it is, very weak at 500 millibars. One more time. This gets us just past the time where the heavy rain, we think, fell to Fort Lauderdale. So it's not in direct connection with this disturbance, although with this development, we saw that precipitation and clouds, or I shouldn't say precipitation, but the clouds from the radar was out at satellite, was out ahead of this development. So whatever it was, maybe is related to this development, but not in a sort of primary first order way. At least looks like that to me. And then this thing gets completely cut off in a very weird spot at a weird time of year. So let's go ahead one more time. Looks like then it tries to reconnect with the invasion from the west of this cyclone. So that's the situation last night, or this morning, yesterday morning, and they keep going. And that fairly stationary disturbance, one more time, gets us to this morning. Now it's finally starting to drift northward, and the circulation around it is what has allowed some of this warmer air and ridginess over Pennsylvania all the way towards Milwaukee. So that's a complicated development, and it doesn't seem like it has any really obvious precursor, at least from the observation maps. We don't have contours of the vorticity. Sometimes one can see features in that allow you to make a little bit clearer delineation about what it might be that's going on in the development. In fact, can we try that, Pete? Let's go to Alicia Bentley and look at the 500 millibar vorticity. Unfortunately, it comes with other things too that might get in the way. We'll try our best. We'll do the North America. Yeah. And And then, I think it's one of the options, 500 relative vorticity. It's only the relative vorticity, but that's good enough. And then we can go back to the 11th. Maybe one more time. Yeah, okay, so there's this little strip of vortex structure from, central Michigan down to about central Oklahoma. Let's watch what happens with that. Does that roll up or something? Not obvious yet. Oh, a little bit. It's kind of rolling up here off the south coast of Louisiana. Let's see. That might be part of the explanation. It looks kind of nicely rolled up by about that time, but it's got this filament structure that goes all the way back. So that's where we saw the dryness in the water vapor. So that's a little filament of vorticity, and it develops a little head, and that head is manifest as a low geopotential height. And it's got, this is the vertical motion signature out ahead of it that is associated with what happened at Fort Lauderdale. So that's as best as we can do. It sounds like a tropical type system, hybrid between a tropical and a development that was initiated by some mid-level or middle latitude vorticity. So this little strip right here is, I think, the thing that kind of rolls up. It's a little head. It's head of a snake. And the geopotential drops in response to that, and then there's the vertical motion. So that's the best I can do with that thing. And while it's getting itself organized during the week, there's a broad southwesterly flow to our west, which got the temperatures quite high to our west, and then there's a gradual sagging of them further and further to the south and east, and that's probably made it the relatively slow warm-up that we had this week and not an abrupt warm-up. I wonder if it was different in central South Dakota and Nebraska. They probably had a really abrupt warm-up with the flow being off the high terrain to the west. We did not get that.
There was a pretty good amount of snow up there too. There was an amazing temperature gradient there earlier this week. It was in the 40s in North Dakota.
In
and 80s
North,
just not far away.
Is that right? Yeah,
Just
Patrick,
because
didn't
it
you
was
tell
so-
me there was 92 somewhere in South Dakota on one of those days?
There was
Or was
a-
that last week?
104 in Wyoming.
Wow. Oh my God, 104. So they must be right downwind of like the Tetons or something else. Oh, that's amazing. So that's all subsidence warming probably. Incredible. See, Morgan used to complain that lake effect is fake snow, but when it's 104, you don't care how it got there. It's not fake 104. It's 104. So you got to play them all. Okay, I think that's all I have for the current weather. And Patrick was going to talk a little bit about the forecast. So thanks for driving, Pete.
That's what the radar looks like.
Oh yeah, I didn't even get there, did I?
Would you like to?
No, go ahead.
Okay. Can we pull up the surface map, please? I just want to look at. The northeast is forecast to get 90s today, so I just wanted to see how close they are.
It was 88 yesterday,
88 yesterday.
On the whole East Coast or just one place?
just the southern northeast coast.
Oh.
Here we go. We already have 90 in Connecticut.
Really?
Wow.
And I know New York City did not get below 70 degrees today, overnight.
Wow.
So
In
this is
Boston.
August, July temperatures.
Well, and Boston's got a 10-knot wind off the ocean, and it's 81. What ocean is that? Is that the Atlantic Ocean like it always was before? Man,
That's a good
it's incredible.
question. Yeah.
Maybe it just switched over. I almost can't believe that. Wow.
All right. Could we go to weather.gov?
Just really quick, I'm going to say something.
Oh, yeah. Sorry.
Yeah, so the really high temperatures in the Northeast, they had their first ozone exceedance event, so like bad air quality yesterday. And it's like 2 months earlier than last year, so that's pretty interesting. I think it's just unusually hot.
And there's no
Widespread,
wind.
Jerry, or just where? Where exactly?
Like in the Long Island Sound.
Oh,
area,
okay.
So like New York, Connecticut, Long Island.
Northern New Jersey, yeah.
Yeah.
Okay.
Well,
Wow.
zero winds, clear skies.
Yeah, that's
all
a
the pollution just sitting
good
there.
way to cook it up, yeah. Wow.
Probably disgusting.
You
Yes,
can't
we'll go to
blame that on
weather.gov
an
and look at that.
They can't blame that on an upper front, not this time.
Could we zoom into
There's
this
a new easter
map?
egg supposed to be the
that's
sea
pulling up?
breeze turning.
Yeah, maybe you're right. Maybe you're right.
That's not what you'd expect.
But I didn't know. You know, I thought that it was westerly, but maybe I
That's
was
weird.
wrong.
No, it's this long.
I mean, they could have just had it didn't look like it was easterly when you were looking at it.
I know.
Anyway, this can work. I can just talk off this. So I'll just briefly point out what's happening here. So first we have red flag warnings just to our north. We've had those for a couple days. Here's those air quality alerts that Gerald was
Oh,
talking
yeah,
about.
look at that.
all along New York, it looks like, and downstream of some of the lakes. You can kind of make out what our next system is going to be with red flag warnings over the desert southwest. This is probably southwesterly flow off of Mexico, and then pocket of cold air. This is winter weather advisories over Colorado. So there's a cold pocket of air and flow off the southwest. There's probably going to be a development somewhere in the short term, and that's what's going to bring us snow for Sunday and Monday, which is bad news, but it's March and April, so the snow won't last for long, luckily. And then, what I was talking about last week, you can see flood watches and warnings up for places that had, feet of snow, and then it was 80 degrees a couple days later. So all this snow is probably mostly gone at this point. And rivers up here, like the river by Fargo, forgetting the name right
The
now.
Red River of the North or something?
Red River, yeah. Floods all the time, but you go from 3 feet of snow to no snow in a couple days, that will flood
That's bad.
some land up there. So let's go to the current outlook maps here. I'll look at the QPF.
The picture that says turn around, don't drown. I can't.
Turn around. Fort Lauderdale.
With the cowboy hat, it's too much.
This one right here.
Wrestling champ too, apparently.
Perfect, and we'll go to the QPF. I always like to look at this to see where it's going to rain or snow, but where it's going to precipitate. So here's a look at day one. So here's that messiness over the southeast due to that upper level low that's just slowly drifting to the northeast. We could kind of make out maybe there's some sort of development going to happen today associated with that storm system, but if we go to day two, it's even more clear that you can kind of make out a comma shape where you have a cold front beginning to sweep across the country and then some wraparound precip to its north. And if we go to day three, we'll see sort of the same, where you can make out the wraparound precipitation due to a cyclonic feature. And I'll go into why this forms and what it does over our area, but it brings pretty good precipitation for the middle of the country. We can go to the day 1 through 2 now. We'll just look at this is the day 1 and day 2 liquid precipitation, so you can make out that comma feature, and a lot of precipitation from Ontario straight down to the Gulf Coast. We'll go day 1 through 3 now. We can see we get into the action here in Wisconsin with precipitation maybe close to 2 inches, maybe some regions 3 inches to our north. And then we'll just go to day 1 through 5. We don't really see that much more precipitation, so this is our main feature in the short term, this precipitation maker and snowmaker for our region and regions looking likely to our west now. So,
Patrick, can we go to day 1 again? I just had
Yeah.
look at the relationship between, the center of the circulation of that decaying tropical, whatever it is, thing is kind of in western Tennessee or eastern Tennessee.
Yeah.
And then there's this heavy precipitation QPF feature off the coast of North Carolina. It has almost the same spatial relationship as if you take that whole structure and move the circulation down to New Orleans.
Yep.
That's the heavy precipitation over Fort Lauderdale.
Yep.
So there's
It's
something
just
persistent
slowly-
there
Yeah. that's
in
right.
that one little sector of this overall development that's at least close to persistent. Pretty interesting.
And there's been just supercells sitting over the Atlantic Ocean over here, just sitting. I think the Fort Lauderdale storm moved like 14 miles in 12 hours or something like that. It was just slowly drifting. And so these are, most likely just single storms just sitting and dumping rain,
Yeah.
which is interesting. I'm sure one of these is still that Fort Lauderdale storm that's just been hanging out. So that would be interesting. Look, I actually, now that we're here, can we scroll down? I remember seeing this. Yeah, we'll click on this picture here. This will show the snow melt. So we can go to the first picture here. So this is April 6th. You can see very decent snow, up to 40 inches of snow in these darker blue colors. Unfortunately, the gradient goes from 20 to 40, so it's unclear where's the maximum, but I mean, there's a wide region of 2 to 3 to 4 feet of snow. Then we'll go a week later. There's
Wow.
nothing, pretty much nothing. Some of these regions go from 40 inches to 0. Minneapolis hit 88 degrees in this time, and there was, as Pete pointed out, high 80s versus 40s where you have snowpack and clear. So extraordinary flooding going on, just due to this single event. And with the rain coming over areas that still have snow, the ground's still probably frozen, even though there's no snowpack, probably continue to produce flooding
Yeah, it runs off a little more.
to our north,
So that's why there's so many mosquitoes in Minnesota, because
Yeah.
all this water doesn't go anywhere. It just melts or sublimates right there, and wow.
Right. And this is all pretty much lakes. If you drive
Yeah.
northern Minnesota, there's lakes everywhere
Talk
too.
about it with it.
Yeah.
There was an almost 40-degree temperature gradient too between the region that was covered in snow and all around it. It went from like 82 to 40 in North Dakota, just
could
because of the
believe that.
snowpack.
Yeah, I could believe that. I'm sure it was cloudy, pretty cloudy up here, and then just bare and sunny.
Yeah, and you know what's of interest there too is that it's not only it's a strong temperature contrast at the ground, but how deep is that contrast? And so what is it? Just a pancake of high PV next to this intense low-level baroclinic zone, and then after that, the atmosphere doesn't even know it's there.
Right.
It's like a thin, film layer almost. Just amazing.
Yeah. All right, so let's go to the AOS looper page, the GFS loops, please. Perfect. We can do the surface one to start. We'll take a look at that storm system. If we could stop it and then go to the start. And let's go 2 clicks to get to 18. So this is a current look from the GFS model. Doing pretty well with precipitation over the southeast and that snow that was analyzed and highlighted in Colorado. And if we just step forward here, we can just keep step forward slowly. We'll see this development off the Rockies, and it'll slowly, ever but so surely, move up towards our region here. You can see we get into precipitation starting mid-Saturday, late Saturday. We'll keep going here. This is likely rain for us. This is now Saturday evening. We can keep going here. We can start to notice there's an intrusion of cold air on the back end of this system. So now, this is midnight on Sunday. We'll keep going. We'll keep stepping forward. We can notice the storm system really wraps up. That cold air keeps intruding and wraps around the storm. And now, late Sunday, we start to get into, now it's probably snowing over us. And this is late Sunday, and we'll keep going. Here, it's still snowing, still snowing, still snowing, still snowing, still snowing, still snowing. So there's a pretty good chance we might see a couple inches of snow out of this.
This will be the 4th April out of the last 5 where we've had more than an inch in a single event if this happens.
Right.
I think it will.
I think it will too. There's a pretty good signal for this. Some models are calling up to 4 to 5 inches of snow for us, which I don't know if I believe that, but I could see 1 to 2 inches out of this.
Let's go.
And so let's step back just a couple clicks. I want to see where it starts snowing. Okay, let's go forward like 2 to 3. Let's keep going. 1 more click. So it's about Sunday 21 UTC. We'll go 1 more click, please. Okay, this is like the rain snow line over us. So 6 p.m. Sunday evening. I can look at this transition from a sounding perspective. We'll pull that up in a second. But so the snow starts Sunday at 6 p.m. and let's keep going to where it stops snowing. I just want to see how long this will last. So these are probably flurries. So, 18 hours of analyzed snow over us and snow flurries, which that's pretty good signal, I would say, for accumulating snow. So let's go to 500 hectopascal from the same look, please. It's a pretty decent cyclone that forms with this system. Perfect, thank you. So here's that system sitting over the southeast and that broad trough that we could make out. Not really too obvious of a vorticity feature yet, but if we step forward, you can just keep clicking forward. We'll notice a region starts to form on the base of this trough, likely from column stretching as this flow moves over the Rockies. You can see it really gets going over Oklahoma, Kansas, and then this little localized maximum vorticity is what brings us development and rising motion in this system, maintaining its strength over us. And as we keep going forward and it starts to snow over us, we sort of lose that coherence. So it's almost a perfect event for us to get heavy precipitation in Wisconsin, but after it moves overhead of us, you sort of lose any real coherent structure, any real PVA by the thermal wind. There's not really a good region where you would look for that in this case, since all of this as we saw in the thickness, is just classified by cold thickness. So we can go back to when it starts snowing, 0 UTC. Let's see, let's go back a little further. So it looks like, okay, perfect. So this is Saturday evening. Let's step forward here, couple clicks, there we go. So we see Sunday morning, it looks like the main region of precipitation will be just to our south, based on where this vorticity maximum is located, and assuming thermal wind coming up from the southeast here. And that region moves over us. Let's go 2 more clicks. So probably the heaviest precipitation, midday Sunday for us, likely rain, and then the snow begins to take over based on this model run here and based on the DFS. And then if we just keep clicking, and you can just keep going, we'll watch this storm system kind of just peter out, it becomes broad. You lose that clear signal of a very strong pocket of vorticity, and the system just kind of gets taken up in the flow to our north and maybe redevelops. I didn't get this far in my analysis, but redevelops over the coast. But it really only affects the northern Midwest, and especially our region here, and probably into Michigan as well. And so let's go to this same look at 850 now. And we can look at the cold air that comes with this storm system. Perfect. So we can already make out a cyclonic flow around low southern Canada. We'll just watch this. We can keep stepping forward here. We'll see this wrap around cold air as the storm system moves up from the southwest. You get this pretty strong region of cold air and cold air advection right behind the storm system. And this is where it starts snowing over us. So it's definitely cold at 850, which is right above the surface. And we sort of stay in this pocket of cold air for a while. So even if it doesn't initially start to snow as early as expected, we can expect flurries probably all Monday. And then we quickly lose that cold air and it becomes warm again, which is the better news, I would say. And it heats up pretty quick. And it looks like we'll stay pretty warm for a while, at least into next weekend, where we might get another shot of cold air here. Not sure about snow yet. I don't look forward this far forward, but I mean, this looks like almost the exact same forecast I was just making, where you have wraparound cold air and precipitation region. So we might be seeing snow 2 weekends in a row, but for sure on Monday and Sunday evening, based on this model.
This would be pretty late. I think the year that I was thinking about was maybe 2019. We had snow on April 18th, which was about 8 inches of snow, and then a couple of years later we had 4 or 5 on the 14th. And so this thing that might come on the 17th would be challenging that for latest accumulating snow. I don't think we've had it as late as April 22nd, but maybe I'm wrong. Not recently, I know we haven't, but.
I hope this was verified. I'm over this snow. I like the warm. Okay, I think I have one more thing on that. Oh yeah, can we go to pivotal weather, please? We'll look at the, okay, let's go to 51 hours on this look. And so we can see here's our storm system, and it's sitting relatively over us, and it's raining based on this model look. And we'll just watch this transition, and we'll actually, you could click near Madison.
Is that the right time?
Yeah, we'll click through here. I learned this cool little feature. So let's go back to 51 hours. Okay. Ooh, okay, we can go forward. That's fine. So this is a look Sunday at noon. You can see we're at 59 degrees Fahrenheit, 10-degree dew point depression at the surface, and we'll watch the winds and the lowest levels. Pretty classic cold frontal passage, but it comes up very nicely on these forecast soundings. So we'll go 1 click forward, and presumably it's raining, so we get cooling from evaporating precipitation, but you can see there's a strong, very clear wind shift in just the lowest levels. And we'll keep going here. We can notice that wind shift gets stronger and higher up in the atmosphere as we keep losing degrees. So now we're pretty close to freezing. I think we go to show map. I believe it's snowing at this time. Yeah, so we're right on that rain snow line. at this time. We can hide the map. And then we'll go 3 more hours in the forecast. This is now, where is it? Late Sunday evening. Now we're most definitely snowing, very saturated at the surface. It's probably melting as it falls. The ground's very warm and it's still 36, but it's most likely snowing as layers just above the surface are below freezing. And you can notice the wind shift beginning to increase in vertical height. So the passage of the cold air keeps extending further and further up in the atmosphere. We'll go another click here. Now we're saturated well up into the upper levels and definitely snowing at this time. And we can show the map here again. Yeah, this is probably our heaviest snow. So where this wraparound cold air hits in association with the precipitation is most likely going to be where we see the heaviest snow. This was looking like it might be to our west, but if this system moves and shifts its track eastward, we might be in this region of heavy snow, just a strong corridor. It looks like Wisconsin's in the bullseye based on the GFS, latest GFS. And we can pull up the exit out of this. We'll pull up just a look at the expected snowfall. We go down to winter, and we'll do 10-to-1 total snowfall.
It's only up to that time, isn't it?
Yeah, that's right. So it just started snowing over us, so we'll go to like 72 hours. This will be Monday morning. You can see maybe we get 2 to 3 inches, but there's this region of localized heavy snow just to our west. So if this shifts over us, we might be in much heavier snow. But I think if we go to like 84, just to make sure the storm system's done over us, maybe we're into 4 to 5 inches based on this model guess. So it'll be a tricky forecast. We might get 23 inches of snow. Hopefully not, but that's probably exaggeration. But the regions could very well see up to a foot of snow in Wisconsin, maybe into northern Iowa, southern Minnesota as well. So this will be something to watch. And Monday looks like it'll be terrible and gross, snowy, cloudy, but then we quickly get back into 50s and 60s right after that. And then one other website I want to pull up. We could pull up a different website. I always have cool websites. So we type coolwx.com, aptly named, coolweather.com, and go to global temperature records, and we'll pull up the USA past week. Could we potentially make this bigger? Perfect. So I'm not sure how accurate this website is. It's someone who is just coding up weather records. But what is plotted is anywhere there's yellow, reds, or oranges are record high temperatures. Anywhere it's blue is record low temperatures. Anywhere you see a white circle around a dot, so I'll wait till it comes up here. These are stations that are breaking the record high temperatures for that station. All-time record highs would be in a black X, but we don't see that. But this shows a clear picture of what we've had, the warmth we've had. So I'll let it loop back. This is April 8th, now April 9th, now April 10th. And we'll see our warmth start out west here, move over us. We set a record high, move over us again, stations to our north setting record highs, and now into the northeast setting record highs. And one of these included 104 in eastern Wyoming, which was 3 degrees off the all-time high for that station.
Wow.
In April. And nobody cares because nobody lives there, but I think it's pretty interesting that that station just out of nowhere almost tied or broke their all-time record high for April.
It's pretty unbelievable.
This is a cool website. It also has like Europe, the globe we can pull up if we just do globe past week. Maybe so we can just see a different animation. So you can just watch all the record highs and lows being broken every single day at different stations. And you can notice our heat was localized to America here. You can see it just keeps populating over America, more so than anywhere on the globe. You can notice there's a lot more record highs than record lows being set. So I had fun just watching these
That's
animations earlier.
Do you have any control over the speed?
No,
Oh,
that's
that's
the
too bad.
only thing that I would like. Yeah, it goes really fast. And you can't go back besides these preset different, like week, month, year, that's it, but it's still kind of fun to watch. So any notes or questions about what I said or talked about?
Oh, thanks very much, Patrick.
Thank you.
Thank you. And for more cool websites. You make a list of them somewhere?
I have a bookmark, so I can.
Oh, okay, all right. You should make a list. They're all good.
The
Yeah.
folder is just like.
We can put them on the Weather Watch page.
Yeah, that would be a good
Patrick's
idea.
Weather Watch.